Hello and welcome to this quick tutorial on how to import a CSV file into Python. We're going to be using Jupyter Notebook. I've put this CSV file into the description box, so feel free to code along with me as we go on. It's just a simple tutorial. If you've used Python before, it's nothing. It won't be anything new to you. But if you haven't used Python before and you're just getting started in football analytics or any type of data analysis, this will be a good quick tutorial just so you can learn the fundamentals really. So yeah, let's get started. Now, as you can see here in the first cell, we've got two of the main libraries you're going to get used to using, Pandas and NumPy. It would be a good idea if you maybe get them saved onto your notes or a Microsoft Word document just so you've got them on hand ready to copy and paste in. So if we run that cell, you'll see a number comes up once it's run through successfully into the squared brackets on the left. You'll see a number 1 there. That just shows that it's gone through okay, no errors. And now the next thing we're going to do is import the CSV file. So to do that, we'd put pd.readCSV and we'd assign it to df equals, so that's just saying data frame equals pd.readCSV, and then you would read in the exact name of whatever you saved the CSV file into your directory. So if you, as you can see here, I've put xa top5 euro.csv. That's what I've named it as, and there are capitals and lowercase in there. And it's very important that you have to put the exact letters you've saved it as, otherwise you'll get an error. So I'll run that through, and as you can see, the 2's come in, so that just shows that it's been run through successfully. So some of the most common errors you'll get are the fact that you haven't put the exact upper or lowercase in there, or also it's not saved in the directory that Jupyter Notebook is searching for. So what's good practice to do is open your notebook in the same directory as the CSV file is saved, and then you won't get that error. So once that's run through successfully, we can have a look at our data frame by calling df.head. That gives you the first 5 rows of your data frame. So as you can see here, we've got many columns. We've got player, nationality, position, and it's only showing us the first 5 rows. So now we get a nice little overview of what our data frame consists of. And now as we go through, df.columns. Now that returns all the columns in data frame. So as you can see there are quite a few. Some we may not find relevant, but we'll move on to that in a moment. So say if you just wanted to select say 3 columns. To do that, you put df, so you call your df, your data frame, and then you put double open brackets, and then you call in quotation marks the exact columns that you want to look at. So for example here, I want to look at the player, the age, and expected assist. So that's XA. And I call it, and then I get, instead of looking at what was up here, all of these, I now just get the select 3 that I wanted, just by calling that simple bit of code there. Next, df.describe. Now that, as I've put in comments here, returns a description of every numeric column in your data frame. So let's have a look at that. And as you can see, you've got the count, so that's just the number of rows we have. The mean, standard deviation, minimum, maximum, just your simple descriptive statistics for each numeric column in your data frame. But maybe you just want to look at one column, and that gives you, and the code below here, df age.mean, so that is again calling data frame, and then in squared brackets you call the exact column you want in quotation marks and put .mean, and that returns the mean of the selected column. So as it shows here, 26.138, and if I scroll up, you'll see that the age mean is exactly the same. So you could have done that for any. I've just given an example there, but yes, that's something that you should get used to looking as you come into your first, when you're importing your CSV file. These type of exploratory data analysis is some things to look at. df.shape, that returns the rows and columns in your data frame. So for example, here we've got 499 rows and 31 columns. The next row is what happens if you might want to drop a column. So it's irrelevant, you just want to get rid of it. So to do that, you call df, so you put df equals, and then you put df.drop. So that does what it says, it drops a column. And then the next bit of code is born. So I just chose a column at random, and you put in quotation marks. So I'm going to be dropping the born column. And then axis equals 1 means it's a column. If axis equals 0, that would represent a row. So you put axis equals 1. So you're telling Python that it's a column. So you run that through, and then if I look again now, you'll see that now the born column, which was here in between age and 90s, I believe. So if I scroll back up to when I first imported in, yes, you can see that born was here. Born was just there. And now when I scroll back down, you'll see that born is now no longer there. And that's because we dropped it. But what about if we may want to rename a column? And that is just here. So df equals df.rename, and then you select the column what it's currently called, and then what you want to change it to. So for example, here I've changed comp to competition and AST to assist. Now that is simply here you'll see in a minute that will change the competition, and AST will change to assist. There's no real reason for me to do this. I'm just showing you how you may want to rename a column. I knew what they meant, but it's just for future, just for you can have a go at it yourself. You can pick any column you want. And this next bit of code is if you may want to say look at a specific column in a filter. So you're going to filter your column. And this is, say for example here, I have filtered the 90s column. So that's the 90 minutes played for this player. The way this column was calculated was they had the amount of minutes that the player played across the whole season, and then they divided it by 90. So that's where you might see like 20.7 or something like that. That's how it was calculated. So to do that, you call your data frame, and then you call your column. So we're looking in df, our data frame, and then we want to look at df90s, and then we're going to set it to be greater than or equal to, that's what this operator is here, 15. That's all this piece of code says. So you have to say df twice. So that's because if you break it down, you're calling in data frame, and then you're calling in data frame 90s, and then you're setting it to be greater than or equal to 15. Okay? So then that gives you, if you look at the 90s now, there should be no less than 15. But that doesn't say create a whole new data frame with that in. So to do that, we are going to call a new df. So we're going to rename it. So it's now called new df equals data frame, which is the exact piece of code we just did in the row above. So you're more than welcome to copy and paste that down. So it's new df equals df90s. So that is, we're calling in to filter it for greater than or equal to 15 of 90s. So we're creating a new data frame with this filter in, and then you put dot reset index and then drop equals true dot copy. So if you're new to Python, this might look like a different language to you, and that's completely fair because it technically is a different language. But all this is doing is reset index drop equals true is when we create this new data frame. If you look at these numbers on the left hand side where it says 0, 1, 2, etc. down here, if we don't put reset index drop equals true, then that's going to carry over, and your index in here is going to be a new column. So you're going to essentially have two indexes. Okay, so we're dropping the old, we're dropping a new index coming in essentially. So that's why you put drop equals true, and then you put dot copy to create a new list. So I've put it in comments down here. That's just a simple steps in case you get confused. But if we call in that new df and then we look at our new df.head, you'll see that there's only one index still, so that's great. And the 90s, although if I do a larger amount, let's do 10, you'll see that there are no 90s below 15. Okay, and to prove that further, just like we did at the start, if you put new df.describe, and as we look up here, you'll see the minimum is 15, and that's because we created the filter up here. So the new df now has only rows that are that have 90s above 15, and if you remember rightly, I believe there was 499 on the count before, and now there's 453, so we've got rid of 46 rows. And the next thing we'll do is we're now going to sort the values by expected assist, and we want ascending equals false dot head. So what this gives us is our new df dot sort values. We're gonna sort it by expected assist, so that's what's going to be what determines who's at the top and who's at the bottom. And ascending equals false. Now that's because we want to start from the highest and not and go down to the lowest. If we put ascending equals true, we're going to start at the lowest and then go and then carry on going until we get to the highest. But that we don't want to look at the worst player in terms of expected assists. We want to look at the top 10. And that's what this gives us here. So now, as you can see, this table here, we start with expected XAs here, and they are going descending. So the best player here, Benjamin Bourgeois, for last season, has 13.2 expected assists, and Mbappe, as you go down, it goes down. So yes, that gives us our top 10 players, but this is quite a big old, a lot of columns in here still. So if we wanted to filter and just look at specific columns, we could do this. So we'd use the exact same piece of code as we did above, which was up to here. So you're more than welcome to copy and paste that down. And then we just select columns. So player, squad, age, pick whichever columns you want to look at. Oh, I have an error. So why might this be? This is because I, if you remember rightly, changed assists to assists. Oh, I've spelled that wrong. And then I have it. Okay, so you have to make sure that that was that all your columns are named correctly. And there you go. You've got player, squad, age, assist, expected assist, and then the difference in there, which is what I added in just there. In a nice little neat table there for you to look at. So then you've got a little bit of insight there. I mean, this tutorial is not necessarily to provide an actual analysis on these players. It's just for you to understand how to import a CSV file and go through some simple fundamental steps that you might want to do when importing that file. And there it is. And so just to recap, what we've gone through is we've imported a CSV file, we've had a quick inspection of the data frame, conducted simple exploratory data analysis when we looked at the descriptive statistics, removed and renamed columns, and filtered and sorted the data frame. If you found this tutorial interesting, please like and subscribe, because there'll be some more and probably more advanced tutorials coming very soon.